Hello everyone, welcome back to the General Chemistry Lecture Series. We're on a new topic here, physical properties and chemical properties. So I just want to say thank you for sticking around if you've seen the first, I believe, 3 lectures. Now we're going to start to ramp things up just a little bit. We're going to be talking chemistry a little more so, and then next time we're going to start to get a little mathy. So be prepared for that. But now it's just another conceptual kind of unit. It's nothing really difficult, but it's something that you might not be able to see now. It's kind of one of those things where you learn and you're like, well, I lack context here. And that might be something that's true for you. But just realize that once you see these terms again, maybe later in the semester, it will make a lot more sense. And what we're going to be talking about today is a physical property versus a chemical property, and a physical change and a chemical change. Very simple stuff. So let's define the two. Let's start with changes. So what is a physical versus a chemical change? Well, let's define it here. A chemical change is a change where the chemical nature, meaning its bonds, its elemental composition, not the arrangement of the atoms, but the way in which they might bond with each other, those kind of things. We'll learn this stuff later, such that it's a change where the chemical composition changes. Okay, so we'll get into some examples and hopefully you'll be able to see, but this is different from a physical change. And in a physical change, it's a change where the structure, and we're going to underline, bold, star that. I can't do a star for some reason. Let me retry. Hopefully I can do a star right this time. There we go. That's a star. Star, underline, bold, exclamation point, where the structure changes. Okay, so what we're going to do in this lecture, because terms are helpful, but they're not something that you should just bank on, right? And that goes for anything in life. Don't just learn the terms that you're learning, learn what they mean. So let's learn what this means, a chemical versus a physical change. Okay. Hopefully you wrote that down if you're taking notes. This eraser is dead, guys. Holy mackerel. Okay, let's define some chemical changes. So you might know what nitroglycerin is. It's actually a funny chemistry story. You have 2 what we call enantiomers of nitroglycerin. One's a heart medication, one's a primary explosive, and a primary explosive is a very dangerous one. So if you ever hear that, stay away from those. So some chemical changes might be an explosion, right? Some sort of other process. You might think like maybe rusting. Combustion is another one. These are obvious chemical changes that you'll see. Gas production. So whenever you see these kind of things happening, these examples, these are chemical changes, because what's happening at the molecular level is that you're forming new bonds, or you're doing something with how the atoms are arranged, and it's causing the actual chemicals, the molecules, the atoms to change. okay, in their composition or formation. So in the example of combustion, right, we kind of saw this in the last lecture. If we take a fuel, right, and let's say that's some crazy hydrocarbon that might look something like that, right? No need to know what this is now, only later. And you have oxygen. Well, remember, that makes CO2 and H2O. We transformed the matter into something different, this fuel and oxygen. Now it's taking on this new form. And that is a telltale sign that there's a chemical change happening when your matter's converted. Remember, how you would notice this is your fuel is probably a liquid. Hopefully in your car, the fuel is a liquid. And when you burn that fuel in your car, you create CO2 and H2O, your exhaust fumes. That is a chemical change happening in your car. Okay, I now want to talk about physical changes and some examples of those. Dissolving salt in water would be one. So, okay, you could do that. Melting something. All right, if you melt something, that's a physical change. Let's say hitting something with a hammer. That could be a physical change. It's hard to put terms to these things because they're not really a termy thing to remember. It's just something that you notice, you're like, oh, that's a physical change. Oh, that's a chemical change. That's how we're approaching this. So dissolving, melting, the malleability of something is important to discuss here. If something's malleable, right, you can hit it, it will deform. Maybe like a softer kind of metal. I'm trying to think, maybe like sodium metal or potassium metal. It's very malleable. You can hit it with a hammer and it will deform it as if it was kind of like rubber or something. So those are physical changes, right? That's all we're going to talk about here. It's a very simple idea, but what we're going to do now, just so I understand that you have it, is we're going to go over some practice problems, okay? We're going to do just 3 practice problems. We're going to talk about them in depth. We're going to say, is it a chemical change? Is it a physical change? Okay? So let's go through them. We already did one, right? A chemical change, but... And some of these you're not going to have context of, okay? So just bear with me. If you don't really understand the chemistry behind it, and in one of the cases it's pretty complex chemistry, it's biochemistry, that's okay. You don't have to. You should just be able to see like, oh, something weird's happening there. Okay. So my first example is that if you've ever went to the store, you've probably bought bananas before. I hope that you have. Because who doesn't enjoy one of these? Okay. And if you've let them sit, the bunch sit on your countertop, you've probably noticed that it browns over time. Or you might buy them even green, and then they go to yellow and brown. What's happening there? This is known as ripening. Okay, so when a banana browns, it's ripening. And what happens is it's a bunch of biology behind it, but basically ethylene gas is going into the banana and signaling some things to happen. So let's think about this. Is it a chemical change or is it a physical change, and why? Okay, so I'm going to bank on the fact that it's probably not a physical change. This is more so of a chemical change. Because if you notice that yellow to brownish thing, and if you've ever felt how the banana feels, if you've ever eaten a slightly over-ripened banana, it's mushy, it's weird, it's different than it once was, and that's indicative of a chemical change. You might also notice that it goes from a more sour taste to a more sweeter taste over time. That's a chemical change. That's the banana basically getting rid of all the acidic species that we're tasting to be very nasty. So the ripening of a banana is a chemical change by definition. Okay, if you've ever cooked with water before and put a lid on, you might notice this. Alternatively, if you've taken a very, very hot shower and you have like a glass door or something, you'll probably notice condensation of water droplets forming on that surface, right, and trickling back down to the drain. Okay, so to denote this, I'll just say condensation. Okay, what kind of change is this? Is it a chemical or a physical change? Let's think about it. And just so I'm a little clear here, you're going from a gas to a liquid, right? Okay, so what did you say? Do you think it's a chemical change? Do you think it's a physical change? Well, I'm going to bank on the fact that this is indeed a physical change. And let's think about why. What is water? Well, hopefully you might know that it's H2O. Now, if you don't know that, that's okay. We'll learn about it. But H2O is the molecule of water, and whether it's flying all around like this or, it's just a nice flowy liquid, it's still water. Did the actual molecules themselves change? The answer to that is no, right? And if we look at what this looks like at the molecular scale, you're not going to need to know any background of atoms yet, but you have all these little dots which are represented of water atoms, right? And if they're in a gas, they're flying all around in all these directions. But once they lose that heat, right, because, when it comes out of the shower, it's at, whatever degree you set it to. But when it's in contact with the air, it's going to begin to cool down. And when it cools down, they're just going to form this liquid at the bottom where they're just kind of flowing on top of each other instead of flying all around. And this kind of relates back to our last lecture, but this is a characteristic physical change. We did not change H2O. It is still H2O at the end of the day. That is a physical change. Okay, let's just do a last one here. This one will be maybe a little easier. I'm going to do my best to draw. It's not great, but I feel like drawing this. If you ever played Minecraft, you know a little bit about this. So you have an anvil and you have a smithing guy, so we'll give him a name. What should his name be? Bobby? If I was a medieval guy, I'd want to be a Bobby. Seems like a nice name. And he's working with this piece of metal and he's smacking it with a hammer. Okay? And then he's going to output a nice, beautiful Claisen sword. Okay? So maybe something like that, right? Okay, so what is Bobby doing? Is he invoking a chemical change or is he invoking a physical change? Well, if you remember what we said earlier, a physical change can encapsulate malleability. And someone who works on an anvil, I think they're called like a blacksmith or something, when they're smacking the metal, they're not changing the molecular formulas of those of that metal. No, what he's doing is he's just deforming the atoms' positions because those atoms are really held tightly to each other. So when he smacks it, he's saying, no, 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 split apart, go in these other directions. And that's what he's doing over and over, and that is a physical change. Another extension question, let's say that he heats up the metal, right? So maybe let me grab this here just for the added effect, because why not? Let's say now that he instead has this heated up, so he has a little flame, right, coming out of a torch. Okay, so there's a flame coming out of the torch, it's heating the metal. Is that a chemical or physical change? Go. Boom, if you said it was a physical change, awesome. When you heat a metal, it typically does not deform it. Now, that's not the case all the time. When you heat something, you might actually get a chemical change as a byproduct as well. But just the matter of heating something to make it more malleable, right? Because when you heat metal, it makes it more malleable, so you can strike it with a hammer and it will deform easier. That's just a physical change. You're loosening up the molecules, but you're not changing them inherently in their chemical composition, just their physical. Okay, that's all I had to say about physical and chemical changes. I hope you guys enjoyed. If you did, please drop a like, comment, and subscribe. Next time, very lengthy lecture coming up. We're going to be talking about measurements, so things like length, mass, density, volume, those things. And then we'll do some dimensional analysis too. So take care, guys. Bye-bye.